Hello everyone, welcome to this session. I am Tezan Sahu, a fourth year undergraduate from IIT Bombay, and today I'll be basically talking about my experience of completing the Google Summer of Code 2020 with the PEcAn project and the stuff that we've been able to accomplish over the last 3 months. So the project has been titled Extending the PEcAn API, which is basically revolving around the fact that we want users to kind of be able to use and leverage the functionality that's provided by the PEcAn project in a remote environment. So we'll delve into the specifics of the project very soon. But before doing that, I would really like to thank all my mentors, Rob, Chris, Alexey, for all the support that they've provided me with, and to also several other community members, maybe Mike, Istem, to name a few, with whom I've had really engaging discussions. And it's been a really worthwhile experience over the last 3 months to be communicating with you guys and being able to develop this API. So without any further ado, let's just dive into what we have in stock for today. So up first, I'd like to talk about the motivation and why. What was the necessity for going ahead with this project? So as we all know, PEcAn project was initiated to basically facilitate easy and transparent modeling of ecosystems. And currently, the most preferred way of interactions for most of the users is through the web interface, which can actually be found on the PEcAn repository in the web directory. But that's actually highly coupled with the PEcAn databases, the thread server, and there are a lot of overheads that an end user might want to avoid if he wants to kind of interact in a remote fashion. So the prime aim of this project was to revamp the existing PEcAn API to allow remote interactions, and also to develop a package which would leverage the PEcAn services without incurring any of these large overheads. So if you look at the diagram over here, the two orange boxes are the ones which were the prime focus of this particular project. Towards the left side, we have the PEcAn library, which is now called the rpecanapi API. And towards the right side, we have the PEcAn RESTful API service, which can be deployed onto any server which is hosting the PEcAn stack so that the library can communicate with it. The potential impact that we actually gauge is the fact that users would leverage the full capabilities of PEcAn directly through a simple R script. Since the rpecanapi API is completely developed using R, so basically now the end user does not have to install the entire VM and start working with stuff. All he needs to do is install a simple package which does not have many dependencies as well, and simply incorporate the calls and be able to use the PEcAn services. This will also facilitate developers across different regimes to actually integrate PEcAn project into other softwares which may require ecosystem modeling and related stuff. So the features that we actually try to incorporate into this API and library are as follows. So we try to enable a very intuitive form of searching, since PEcAn involves a lot of models, sites, PFTs, inputs, formats, and a hell lot of stuff. So we wanted that users should be, before actually going and submitting something known as a workflow, the user should be able to search for the right parameters that he should be inputting into the workflow. So yeah, we enable intuitive searching based on simple substring matching. And once a user finds some relevant information, he can actually get more information about these entities based on their IDs. And these details can also be fetched for workflows, PEcAn workflows and runs. Now, the most important part, or rather the most essential part of this entire project, could be attributed to the fact that we are able to remotely submit PEcAn workflows for execution onto any server on which the API is deployed. So we provide users with the support to basically have the parameters of model, specify the parameters of models, sites, PFTs, etc., and to create to a function which actually creates a workflow which is encapsulated away from the user and submits it to the PEcAn server. Other than that, we also support XML and JSON format documents to be submitted as workflows, primarily because the PEcAn the existing format of submission is generally the PEcAn.xml file, and which can also be changed conveniently to JSON formats as well. Now, apart from submission, once the workflow is executed and we get the results, we also have a provision to download any relevant files. These could be inputs which are used for a specific workflow or a specific run, or even any random input file that is actually available on the host without actually going into which run or which particular workflow it belongs to. Maybe a user wants to find the inputs that are required for a specific model, so he can do that as well. He can download that and look it up locally as well. Lastly, once the run is completed, we have the results, etc. We can actually plot the variables against one another, and the plotted image gets returned back to us. The entire code for the API server has been Dockerized for a streamlined deployment into the Docker stack, which PEcAn currently uses. And yeah, so with all these features covered, let's jump right into the live demos. So today I'll actually be talking about how we should be using the rpecanapi API library, and I'll also be talking about the different endpoints that are available in the PEcAn API server, which can be done through an interactive Swagger documentation, which I'll go through later. So yeah, let's dive right in. So before we actually start off with this demo, I'd like to just show you that this is the rpecanapi API documentation, which is live as GitHub pages. So you can actually look at the installation and the getting started, which talks about the detailed usage. And we also provide a vignette for users to understand what all they can do with the functions, and also in order to submit in order to first figure out how to build a workflow and then submit the workflow and do post-processing, etc. Okay, cool. So before we actually get started with the demo, I would just like to point out that for this demo purpose, we'll be using a locally deployed API server, which can be done by going into the PEcAn/app/API and running the entry point. We have the server up here. The code for this can actually be found on the repository up here. It has the README and the stuff for running the tests, etc. Cool. So let's get started. And first we'll actually add the library up here, and then the first thing that we do is basically to create a server, or rather connect to a server using the connect function. The URL over here will be our local host 8000, since that's the port on which it's running. For now, I'll just keep the username and password empty. Now we can actually go ahead and check if the server is live or not. Yeah, it is live. And we can also check the status of the server. Oh, sorry. Cool. So I do get the details about the host to which I'm connected to, or rather interacting with, and the specifics of the PEcAn versions, etc., which are deployed on the host. So currently, since it's deployed on local, so these details are unavailable. But something to note over here is that this is a host where authentication is required. You see the value true over here. So creating or setting up the server without any username or password would not suffice. So therefore, we can actually just go ahead and use our default Karya and Illinois as our credentials to create the new server. These couple of calls that I just showed you, which was the ping and the status, actually do not require an authentication, even if the server is a one which requires authentication as such, only because these are very trivial endpoints and do not touch the data that's stored on the servers. So with that being said, let's just go ahead and try out a few things like the searching and getting information. So let's first search for models. I have the server in place, and let's say I want to search for models with the name SIPnet. I get a total of 4 such models with different revisions. Now I can also, since these are all substring based searches, so I can also have a revision when I want to, let's say, search for the models which have SIPnet and have 136 in the revisions. Cool, so I do get only two of them, which is R136 and the 136 out of these four earlier. So by default, these searches are case insensitive, but it can be made case sensitive as well using the ignore case. Set it to false. By default, it's true. And now I can see that there are no models available because the SIPnet over here is in small, whereas all the other SIPnets are in the database are in caps. I can just show you one last thing over here. Is that if I change it, I do get the valid result as expected. Similar things can be done for, let's say, sites. I add the server, and let's say I want to search for the ones which have throught in them. So I do get 3 of them. I guess this one is the most popular, that one which we will be using in future as well. Next thing is to search for some PFTs, which are basically your plant functional types. I'll try to search for some server, and yeah, let's have the PFT name containing, let's say, conifers. I do get 4 of them. 3 of them are actually associated with SIPnet type, and 42 is the one which we will actually be using for the workflow that we'll be submitting later. And we can also actually search for inputs, because inputs are a major requirement for models. And the filtering of inputs is actually done based on model ID, to which model ID, site ID, the format of the input, as well as the availability, as well as its availability on the host. So for now, let's just restrict ourselves to this particular SIPnet R136 model, the site being 772, and let's say we want to use our current host, which is basically is this. So let's search for it, and yeah, I do get a bunch of inputs over here. So I guess primarily we'll be interested in this climate input, which has an ID of 19003. So with that, I guess I've almost covered almost all the search functionalities. Now I'll actually delve into getting the specific details for a particular model or site, etc. So that can be obtained using get model. I just have to specify the server and then maybe mention the respective ID. I do get over here the fact that the SIPnet models actually support these 2 particular inputs, and one of them, which the metadata is actually required, while the other one is an optional type. So while submitting the workflow, we'll actually supply this 99,000,003 as the metadata for this. Similarly, we can actually go ahead and search for the get the information about the site that we were looking for. And here you get a bunch of information about the site. Similar thing can be done for our PFT. Let me just look up the PFT ID that we were looking at. So yeah, it was 42. So let's have this 42. And yeah, I do get information about the definition, the type, etc. Okay. Now, one more thing is that once I look at a particular input file, or rather any file from this particular search inputs function, I can actually go ahead and download it locally as well. So which can and manipulate it later. So this can actually be seen using download input. And let's say the input ID, let's say I wanted to download this particular file. I'll just paste it up here and save as, I'll just save it with, let's say, input test. And yeah, I do have the file up here. As you can see, this contains all the data. It's been downloaded from the server. And yeah, we're good to go with this. So with all this data in place, we are actually good to start off with the submission of a workflow. So as I mentioned earlier, we can submit workflows in various formats. The first one that I'll talk about is by leveraging the IDs and stuff that we have actually searched for and got information about. So instead of typing that out, I'll just go to the documentation and just pull this code, so that, because it's basically the same thing that we have been doing so far. The model is the separate R136 model. The site is 772. We have the template confer as PFT, and these are the start and end dates. And again, we have the metadata as I had said. The point to note over here is that the previous API that was initially developed allowed only one PFT per workflow. But with the current implementation, we can have a list of PFTs in the form of a vector, which can be input to the function. So now I go ahead and submit the workflow. And yeah, it's submitted successfully with this particular ID. I can also actually go ahead and check to see the status. So yeah, it is running, as you can see over here. The fun thing to note over here is that I can go ahead and actually check the status of the workflow from the R package itself. So the thing that I just need to do is to copy the workflow ID and paste it up here. As you can see, it's done with the ensemble as well, and I guess in some time it should be done. Yeah, in real time I see that it's finished as well over here. So now I can go ahead and grab the details of the workflow by the get workflow function, specify the server and also the workflow ID. And here's a bunch of information about the workflow, where the data is stored, etc., the properties that it has, the number of runs. And here, these are the files, different files that are related to that particular workflow, which can be downloaded as well. So I'll just show you one such download. So we can use the download workflow file. We specify the workflow ID, and then we also specify the let's say I want the PEcAn configs.xml file from here. The file name can be specified. And yep, so as you can see, it's been downloaded up here and we can view it. This is the configs XML. Cool, so I can also go ahead and check out the different runs that are associated with this particular workflow. Again, all I need to add is the ID of the workflow. And it tells me that this is the particular run ID which is associated with the workflow. Now I can go ahead and get the details of the run as well to see what all it comprises of. Over here, as you can see, there's a lot of information, generic information about what ensemble it belongs to, the model, the site that has been used. And here, the interesting things to note over here is that it tells you the bunch of inputs that are available and the bunch of outputs that are also available, which can actually be downloaded to your local machine and then processed later. Another interesting thing to note is over here is the variables. These are some things which we will actually go ahead and use when we start plotting variables against one another from the output of a run. So for now, I'll just show you an input download. So let's say I want to download the readme.txt, or let's say I'll just download the sipnet.clim file. That will be an interesting file to look at. So we go ahead and download. This time I use the download run input because it's specific to a run. I do have so let me just paste in the file name and I'll just go back and claim the run ID from here. So yeah, with this we're good to go. And as you can see, the sipnet.clim file has appeared over here and it has the necessary data which was there on the server. Similarly, we can download the output files as well. They are the netcdf files. I'll use the download run output over here, and let's say I download the 2003.netcdf. And yeah, as you can see, this is the file up here, which is, I guess, a binary file, so it'd be difficult to show it over here. Never mind. So you can see it's not empty. Cool. So with that, I've shown you the basic features. And another thing that I'd like to note over here, like you guys to note over here, is the fact that apart from submission of the workflow by the user-defined parameters, we can also go ahead and submit XML and JSON files, because XML is something because we incorporated because PEcAn.xml is the generic way of submitting workflows as of now, and with minor modifications, it can be converted to a JSON as well. So we do support both of them. So for the sake of completeness, I will just show you this XML submission. So I add the server up here, and the file name is actually called api.sipnet.xml, which is very straightforward XML config. So, and once submitted, again, you can see it's submitted successfully, and I can get the workflow status using this function for this particular workflow. Yeah, it's in transit. It can also be seen here on refreshing. It's completed now. Good. So with that, we come to the very last leg of this particular demo, in which I'll actually show you how to plot variables against one another from a given run. So as we had noted earlier, that this is this was the particular run which we just downloaded stuff from, and now let's say we want to plot a couple of variables. So the function for that we have is plot run bars. Here we again specify the server followed by the run ID and the year. So let's say this contained information for the year 2002 and 2003. So let's say we want the information for 2003. So I'll just add that. And then we specify the variables that we want to plot against. So the y variable that we want, let's say, is simple npp. And if I don't specify any other x variable, it will by default take it as time. So let's just run it and see. As you can see, a plot.png has appeared over here. If you go to it, this is the net primary productivity for the year 2003, as you can see over here. Another thing is that now let's say I want to plot two variables. Let's say we go ahead and try to look up the total respiration versus the soil respiration. So the y variable being the total resp, and the x variable being the soil resp. This can also be taken care of. And let's say I want to save it as I want to save it as xyz.png, not the default name. You can name it anyway. As you can see, there's an xyz.png that's appeared up here, and which contains the required plot. So yeah, with that, I guess I've covered almost all the aspects that this rpecAn API library is supposed to provide users with. And as I mentioned earlier, this is the documentation. And okay, guys, so the last thing that I would like to leave you all with is the documentation, or the interactive documentation of the PEcAn API server. As you can see this, it's deployed on Swagger, and you can find all the list of endpoints that any remote user can connect to. So you have the ping status, then stuff related to the workflows, the runs, models, sites, and a lot of other bunch of stuff. And it also contains the exact schemas of the responses and the requests. And just to show the way it interacts, it allows users to interact with the servers by the documentation itself. So let's connect to the PEcAn Tezan server, which is basically the one which I used for the testing purposes. And let's say I just want to ping it. I go ahead, and yeah, I do get a response. And let's say I want to look at the status over here. So go ahead. And yeah, cool. I do get a status. It contains all the PEcAn specific and the host details as well. So as you can see, having this API does not limit a developer to only the R library that we have developed so far. I mean, a user can go ahead and use any specific language, use for example, like Python. You can use the requests library to connect to our API and leverage all the functionality. So it's that dynamic. I guess I'm done with my demos. So yeah, I'll be sharing the slides, so do check out the use of these links, which are related to the documentation as well as the code for rpecAn API and the API server. And it was really great to have you guys on board for this session. And with that, I open up this floor for questions that you guys may have for me. Thank you so much.